All right, this is compound inequalities. We're on 1.7 part 3. Two or more inequalities can be joined by intersection, which is an and, or a union, which is or. Okay, so things get a little bit more complicated here. Just to explain to you the difference between the two, I'm going to go over intersection first. The solution set to the compound inequalities joined by an intersection is all values that satisfy both inequalities. This is often denoted by what looks like an upside down U. Okay, so this U is read as an and when you talk about set theory. So we're talking about intersection. So when we do intersection and we draw graphs, we're going to look at overlapping values, right? Overlapping values. So basically, what values are in both inequalities, okay? So you'll see them overlapping. You'll see what I mean in a little bit. Okay, so now we're going to look at union. A union is designated by what looks like a U, so that one's easy to remember. And all values satisfy either inequality. So this is an or. Union, it goes with or. And we're going to look for everything in both solutions. Okay, everything. So you're going to look for the far left value to the far right value. Okay? And again, I'm going to show you what I mean in a couple minutes. Okay? So let's go ahead and move on and actually do an example. So this comes from actually set theory. So this says, let set A equal the elements 1, 2, 3, 4, 5, and let set B equal the elements 3, 4, 5, and 6. For part A, it says find A intersect B, or you could say A and B. Okay, so I'm looking for common elements that are in both sets. Okay, so common elements. And guys, I don't know about you. If I can't read it, you probably can't either. So I'll rewrite that. Common elements. So what's common to both? So if I look at the elements, I see that 1 is not common to both because it's in A only. 2 is not common to both. 3 is in A and B. 4 is common to both. And 5 is common to both. So the overlapping values between A and B are 3, 4, and 5. So A intersect B, or A and B, the answer of this would be elements 3, 4, and 5. So you're looking for overlap. Okay? So let's check out the next one, part B. Find A union B. Okay. So A union B means A or B. So I'm looking for everything. So I'm going to include everything that's in set A and in set B. Okay, everything that's in set A and in set B. Okay, so in set A, I have 1, 2, 3, 4, 5. And set B has 3, 4, and 5. I already accounted for them, but it also has 6. So everything that's in set A and in set B, and I should put or in set B because I don't want you guys to get confused. So let me do that. Set A or in set B. Okay, so for A union B, we're including everything that's in set A or in set B. So 1, 2, 3, 4, 5, 6. Okay, I hope that makes sense. So again, and overlap, or everything. Okay, so let's look at 1.7.3. Use graphs to find each set. Now, it says I have -4 going to 0. Okay, so let's graph that. So -4, -3, -2, -1, 0. So if I graph that, negative 4 going to 0 is this. Okay? Now it says negative 2 going to 1 and including negative 2 going to positive 1. Okay, so I need to include 1 now. I'm going to graph it below. So negative 2 is included, and I'm going to the value of 1. Okay? So remember, I'm looking for overlap. Where does this overlap? Okay? So it overlaps at negative 2, negative 1, and it goes to 0. And then it stops. Okay? So where does it overlap? So the answer to this would be negative 2 is included, and it's going to 0, which is not included. Okay? Well, actually, you can include it because below here, 1 is included. So let me fix my mistake. That should be a square bracket. And again, the reason why is because the bottom one will supersede it because that 0 was included in the bottom one. Okay, so negative 2 to 0 is the overlap. So now let's look at this next one. We have negative 4 comma 0 union negative 2 comma 1. Okay, so let me do this number line again. Okay. So I'm going to give myself a little bit more room this time around. Okay, so I'm going to graph negative 4 to 0 in black. So negative 4 to 0. We're not including those endpoints because the inequality sign didn't have us do that. Okay, so there's my graph of that. Now I have negative 2 to 1. Okay, so negative 2 is included, and I'm going to the value of 1. Now this time around, I am doing union. That means I include all elements in both solution sets. So I'm starting and I'm looking for the far right value going to the far left value. Okay, so I'm looking for everything that's in both of these solution sets. Okay, so the far left value, when I look at it on the graph, is negative 4. It's in parentheses, right? And then the far right value is 1. So the answer is going to be negative 4 to 1. Okay, so again, overlap means and, include everything means or, look for your far left to far right values. So two inequalities express an intersection can sometimes be written as a compound inequality if they are comparing the same expression. So for example, let's say that I have x plus 1 is greater than or equal to 4, and x plus 1 is less than 9. If you notice, x plus 1 is in both of these, right? So we can sandwich x plus 1 between 4 and 9 and write this as 4 is less than or equal to x plus 1, which is less than 9. Okay? This allows us to solve both inequalities at once by performing each operation on all three parts of the inequality to isolate x in the middle. All right. So I am going to stop the video here because I don't want the video to get too long, but we're going to pick up and we're going to see an example of how to solve inequalities by solving the middle portion. So we're going to pick up on this, and this is going to be part 4. So thanks for watching. Please watch part 4 next.